Hello and welcome to the programme. My name is Rex Taylor. I'm a training captain with Air Tours International on the Boeing 757-200 and 767-300 aircraft. We're here at 6:30 in the morning in the Air Tours check-in area at Manchester Airport. It's the 31st of October 1997. Air Tours operate a fleet of 7 Boeing 757-200s, 3 767-300s and 10 Airbus A320s on operations as far as Australia, the west coast of Africa, the east coast of the USA. Today we're going to be taking a flight from Manchester Airport to Dalaman in southern Turkey on the 757-200 aircraft. I'm going to meet the rest of my crew now, collect the weather, and we'll see you on the aircraft. Welcome to the cockpit. First of all, I'd like to introduce you to my first officer today, who's Dave Wood. We've completed our planning in our planning office. We've collected the Met and we've checked on any significant NOTAMs for the airfields involved. We're quite happy that everything is fine. We've just closed the doors and we'll be starting our engines very shortly and getting underway. We've just got to complete our flight deck briefing now, and then later on in the flight I'll be introducing you to the various systems on the aircraft and running through a description of those with you. So this morning it's going to be a standard left-hand seat departure from Manchester off runway 24. The weather, as you can see, is very nice here this morning. We've got no problems coming back into Manchester if we require that. So we'll have standard calls and drills. During start and taxi, I'll talk to the ground crew and cabin crew. You talk to air traffic and stand by with the checklist. If we've got any problems when we're taxiing, I'll just bring the aircraft to a halt, we'll set the parking brake and I'll call for the required checklist. For the takeoff itself, I'll line it up on the runway. We'll stabilise the power at about 1.2 EPA. If you call me power stable, I'll call select EPA. If you then call me 80 knots, V1, rotate. We'll stop for any malfunction at up to 80 knots. After 80 knots, we'll only stop for a fire or a major engine malfunction confirmed by 2 parameters. In the event of a call of stop, I will close the thrust levers, select reverse thrust. If you can monitor that the speed brakes deploy and that the auto brakes are operating normally. If they fail to do so, notify me. Once the aircraft is safely coming to a stop, then you can notify air traffic and tell them we're abandoning the takeoff. Any failures after V1 will continue the takeoff, climbing straight ahead. There is no emergency turn on runway 24 at Manchester. So we'll just clean the aircraft up, climbing straight ahead, put the autopilot in, and then consider our options at that stage, but generally to come back in here to Manchester this morning. We're expecting everything to go quite normally, so we're expecting a normal takeoff, and this morning we're expecting to go on to a Stockport 1 Romeo departure. So if we just have a look at that now, we're working on plate 103C, 12th of January 96. The transition altitude out of here is 5,000 feet, and we've got a worst case sector safe of 3,500 feet. So moving on to the notes at the bottom, we've got standard speed control of 250 knots below 10 unless cleared by air traffic. And on the Stockport 1 Romeo, we're climbing straight ahead to 3 DME on the MCT VOR. So we've got that displayed on the number 2 VOR set, and it's displayed in manual. So at 3 DME, I'll call for heading select, and we'll turn right to track 345. So I said initially 345 heading up there till we see what the wind is doing. We track along there to 8 DME from MCT, and then we turn right to intercept the Wallasey 085 radial, which I've set pre-selected under here. So we've got Wallasey and the 085 radial should we need it. But if all goes to plan, once we've made the turn in heading, providing the map, which I've got on my side, looks accurate, then we'll just call for LNAV and follow the departure. And that will route us towards Stock intersection. The altitude restrictions along the way are to cross MCT 7 DME at or above 2,500 feet. The 33 DME from Wallasey and Stock intersection at 5,000. So we've got 5,000 selected on the MCP as our stop altitude. Any questions?
No questions at this time.
Okay. The before start checklist to the line, please.
Okay, internal, external, pre-flight.
That's completed.
Oxygen.
That's 100% checked.
Passenger signs.
They're on.
Instruments.
Are set.
Altimeters.
1033 is 3 times and we're showing 220 feet.
Airspeed bugs.
The airspeed bugs are set at 133, 135, 141 is our V2, 174 and 214.
And that checks my side. Thrust rating.
The thrust rating is set to a D-rated takeoff 1 and 59 degrees. That's set.
FMC.
The FMC is set.
Park brake.
That is set.
And that's to the line.
Okay, Dave, if you can call for push and start now, but just remind you that we do need to start on stand here.
Yep.
Ground, good morning. It's Tourjet 179 Papa, stand 69, requesting start only this time, sir.
Tourjet 179 Papa, good morning, start approved, stand 69.
Start approved, stand 69 for Tourjet 179 Papa.
Okay, have the before start checks below the line, please.
Doors.
The doors, the lights are out.
Trims.
Okay, just for the moment, we're staying with the external power in for the moment, okay, for the start here. So the trims we've got set to 4.5, 0 and 0.
Fuel load and pumps.
The fuel load is checked at 30 tons and we've got 6 pumps selected on.
Pack selectors.
Are off.
Red anti-collision lights.
Is on.
And before start checks below the line are complete.
And 2 rotation, and 1 rotation, and we're just waiting for 25% N3, which we've got now, and the fuel is going on. Just looking for a rise in our EGT. And the number 2 engine is stable. Okay, and we're turning the left engine now. Again we have N3, oil pressure, N2, N1, 25% N3, and the fuel is on. Again we have an EGT rising. And the engine is stable.
Ground from Tourjet 179, Papa stand 69 requesting push.
Tourjet 179 Papa, pushback approved.
Push that. Back approved with Tourjet 179 Papa.
And we're off blocks at 05.
And ground Tourjet 179 Papa request taxi.
Tourjet 179 Papa, pull forward to behind the green TriStar on your left hand side, please.
Roger to pull forward until the green TriStar Tourjet 179 Papa.
You've got the tug clear on that side.
Clear on the right, Rex.
And flat 15, please.
15 selected.
Okay, flight controls when you're ready, Dave, please.
Ready for tops.
Tourjet 179 Papa, continue for the holding point now via the east link to QNH 1034. The 76 you can see ahead is turning right.
Roger, via the east link for 24, once the 76 has gone through, Tourjet 179 Papa.
Okay, well he's turning right now, so we're cleared all the way through.
Okay. Tops are full and free.
Okay, if you're ready for the rudders, they're coming now. Full left,
Full left.
centre,
Centre.
full right,
Full right.
and centre.
Centre. And engine page you have.
Yeah.
Tourjet 179 Papa, right now via taxiway 1, please.
Roger to Taxi me 1 for 2jet 179 Papa.
It's going to be a right
You'll
turn.
be overtaking the south 2000.
Roger, that's copy 2jet 179 Papa.
And we'll have the before takeoff checklist to the line, please.
And flaps,
The flaps are set to 15.
flight controls,
They've been checked.
takeoff briefing.
The takeoff briefing is reviewed. We're going to be taking that, just run through it, straight ahead to 3 DME, and a right-hand turn to track 345. And we've got a modified noise abatement procedure here at Manchester now. So 1,500 feet for climb thrust, and we'll start accelerating the aircraft in VNAV once we get to 3,000 feet.
And that's to the line, Rex.
Yes, thank you.
2jet 179 Papa, call the tower now 11862, bye-bye.
11862 for 2jet 179 Papa. Bye-bye, sir. Tower, good morning. It's 2jet 179 Papa with you, and we'll be ready on reaching.
2jet 179 Papa, good morning, I'm calling back.
Okay, we just take the TCAS on now, then we can have a look and see any traffic on the approach that's coming in.
TCAS, system test, okay. 2jet 179 Papa, behind the landing ATP, onshore files, line up and wait 24.
Behind the landing 18, line up and wait for 2jet 179 Papa.
You are clear on the approach.
Thank you.
And continuing, cabin secure,
Cabin is confirmed secure for takeoff.
transponder,
Is TARA
lights,
are on.
before takeoff checks are complete. Thank you.
Digit 179 Papa, clear takeoff 24, the wind is 240, less than 5.
Clear takeoff for 2jet 179 Papa.
Okay, all set?
Set here.
Okay.
Stabilized.
Select EPA.
Thrust set. 80 knots.
Check.
D1. Rotate. Positive climb.
Gear up.
Digit 179 Papa, contact control 12665, good day.
12665 for 2jet 179 Papa.
Climb thrust.
And control, good morning. It's 2jet 179 Papa with you passing 2000 for 5000.
Digit 179 Papa, no speed restriction, maintain 5,000 feet on reaching.
No speed and maintain 5000 on reaching. 2jet 179 Papa.
Heading select. VNAV. Flap 5. And the map looks good. LNAV, please. Flap 1.
Speed good. That one selected.
Thousand to go.
That checks.
Flaps up.
Speed good, lap up selected.
Manchester, Tourjet 179 Papa, approaching 5,000.
Tourjet 179 Papa, climb flight level 110, fly heading 360.
Recleared 110, heading 160 for Tourjet 179 Papa.
360 the heading.
360, heading north.
Heading 360 for Tourjet 179 Papa.
Okay, 360 the heading, please. And climb and VNAV, please.
VNAV you have, 110 you have.
You can release the cabin crew.
And setting 1013 my side.
1013. And the after takeoff checks, please.
Okay, after takeoff, landing gear is up and off, flaps are up, altimeters 10, 13, passing 5, 4 now. After
Check.
takeoff checks are complete.
Tourjet 179 Papa, turn right heading 090.
Turn right 090 for Tourjet 179 Papa.
Heading select 090.
090.
Seen.
And engine out to 232.
And central to pilot command, please.
And center command you have.
So we're now in the cruise at 39,000 feet. Sure, you can see from some of the takeoff filming there that we were really pushed for time to make our air traffic slot departure out of Manchester. So it's really quite intensive in the initial, from the engine start, taxi out, initial climb and climb up to cruise altitude. Things are happening quite rapidly. The 757 is typical of modern twin-engine aircraft in that it has a phenomenal climb capability on 2 engines, so we're climbing up through the levels very fast, a lot faster than you would do in a 4-engine aircraft in a similar situation. So we get up to cruise altitude fairly quickly. We had the odd break through air traffic holding us for other traffic, but we've got a fairly swift climb up to 39,000 feet. Earlier this morning, Dave and I were checking through the routing, and we've entered that earlier this morning in our flight management computers down here, and we're now heading off initially towards the Dutch coast. So we're heading towards Amsterdam at the moment. So we've crossed over the North Sea, close to the Dogger Bank, down towards Amsterdam. From here we'll then be heading off towards Frankfurt. That will then turn us towards the Austrian border, heading down a little south of Vienna. And then the routing now, which has become the common routing, is taking us down through the old Eastern European countries. In the past we would have routed over Yugoslavia, virtually the entire length of Yugoslavia going down to Turkey. Now we generally route through Austria, down through Hungary, Romania, into Bulgaria before crossing over the Turkish border and then heading straight down through Turkey towards the southern coast at Dalaman. The weather conditions that we checked earlier, good weather all the way down to Dalaman, and it's a very pleasant morning in Dalaman. Nice and warm and generally clear with just a light southerly wind blowing there at the moment. When the Boeing 757 was first designed by Boeing, it was designed as a direct replacement for the Boeing 727, which was a 3-engine, 3-crew aircraft. They wanted the 757 to be a 2-crew aircraft operating short-haul and medium-haul routes. So one of the requirements to change from a 3-crew to a 2-crew aircraft was to try and reduce the workload during abnormal operations. Part of that was achieved by installing modern EFIS, electronic flight instrument systems, onto the aircraft. the presentation as displayed by the EFIS is displayed on this aircraft between two instruments, the ADI, which we have here, and the HSI displayed below it. The ADI, which is now a completely electronic representation, will be recognized as many as basically an artificial horizon, which has been present on most aircraft for the last 40 years. We have a standby example over here of a basic horizon. And you can see, I think, if you look into the center of the instrument here, that we have exactly the same representation of a horizon in the middle of our ADI. So we've got our blue section representing the sky, the brown representing the ground, and superimposed on that we have an aircraft symbol. If I turn the flight director off, you'll be able to see the aircraft symbol more clearly. So we can see the wings of the aircraft, the dot in the center representing the nose of the aeroplane. So at the moment we're flying along with our wings level with the horizon, and the nose is actually about 2.5 degrees above the horizon, which is the normal cruising position on the 757. So basically displayed on the ADI, we can display various amounts of information. In the past with electromechanical instruments, there would have been a large number of pointers, failure flags, all displayed on the instrument. Any one of these could have failed or stuck in an unscheduled position, and we'd have ended up with an instrument requiring repair. On these electronic instruments, we don't suffer those type of failures, and these sort of instruments have been proven now to be certainly 7 times more reliable than conventional instruments, and as time goes by they get more reliable all the time. What they also allow you to do is they allow individual customers and airlines to specify their own presentations that can be presented on these instruments. So for example, here we have the ground speed indication up in the top left hand corner. So we can see at the moment we've got a ground speed of 450 knots. So that would be equivalent to just over 500 miles an hour. On the left hand side here we have a fast slow indicator. So we can see our magenta bug is in the center of the scale, so it's showing us that the aircraft is flying at the demanded speed. Full scale on this fast slow indicator would be 10 knots. So if we saw the magenta pointer move up alongside the F, we'd be flying 10 knots faster than our scheduled speed. Again, if we saw it slow down to abeam the S, we'd see we were flying 10 knots slow. Along the bottom on this instrument, we have a set of FMAs, flight mode annunciations, to tell us what is happening with the autopilot system or flight director system on the aircraft. Again, for various customers, they might display the FMAs on the top of the screen. They may have a speed tape displayed down the side of the screen, and that's purely a customer option. So we can display other information also on the ADI. We can display the flight director bars that we were showing a little earlier. I'll just turn those back on now. So we can see now our flight director bars displayed in the center of the screen. Normally we'd expect those flight director bars to be centered if we were actually flying the aircraft in the way the autopilot would wish it to be flown. We can also display other information. In this particular case, we can actually display our ILS information or instrument landing information, and I'll just turn that on now. You can see now that we've got two scales which have appeared. A horizontal one at the bottom, which represents the localizer, and a vertical one, which represents our glide slope or angle of approach into the airfield. If we were at a lower altitude and actually picking up the ILS system or an ILS receiver at the moment, pointers would appear. In this case, we're just displaying a localizer pointer at the moment, and a similar magenta pointer would appear on the glide slope scale. Normally in the cruise, we wouldn't want to display the ILS information. It's just basically a distraction here at the moment. So I'll just turn that information off again. Even though the EFIS systems are extremely reliable it's required by both Boeing and the certifying authorities that we have basic backup instruments in the event that we have a failure of these EFIS systems in flight. So we are required to have standby instruments to give us all the information contained on that ADI from an alternative source. So fitted to the aircraft, as we pointed out earlier, we have a standby artificial horizon. We also have other standby instruments to fit along with that. We have a standby airspeed indicator and a standby altimeter. So that in the event that we lost completely the ADIs on both sides of the aircraft, because there's an identical system on the first officer's side of the aircraft, we've still got a basic set of flight instruments that we can use to fly the aircraft. So if we come back to the ADI just for a minute and look again at our flight mode enunciators on the bottom here, we've got 4 indications here at the moment. The first one is showing speed AT, which is speed auto throttle. So it's showing us that the speed of the aircraft at the moment is being controlled by the auto throttle system. The auto throttle system is being driven by the flight management system at the moment. We're also showing under that we have VNAV path, so it's showing us that the vertical profile of the aircraft is also being controlled by the flight management system. On the right hand side here we have a command indication which is showing us that we have an autopilot engaged in the command mode, so the autopilot is actually controlling the aircraft at the moment. Under that it is showing us LNAV, which is also showing us that the flight management system has control of the horizontal navigation of the aircraft. We'll now move on to the HSI, which is displayed directly below the ADI. The commonest form of display that would be used during normal operations of the Boeing 757 is a map display, which is driven directly from the FMCs. The map display, as you can see on the screen here, is showing the aircraft basic position. The white triangle represents the aircraft. The apex of the triangle is where we are at this time. The magenta line leading away from the aircraft is showing the route that is programmed into the FMC and that is being flown at this time by the autopilot. Most of you would recognize the more traditional display that we would have here. And if I select it now over to our basic VOR display, I think you'll recognize the display we have. So if we put it into our basic VOR display, we can see the basic representation of a compass, and our VOR information is being displayed on this beam bar in the center. We show a number of bits of information around on the screen. We show our distance to run to the VOR. We show the aircraft heading, and down in the bottom corner here we show what type of information we're displaying. So we're displaying VOR information on the left hand side and our wind direction and speed. So we're showing a wind direction of 101 degrees at 10 knots at the moment. We can also display ILS information in the same basic form. So I'll just select it across to ILS information now. And we see in ILS that we have a very similar display, a full compass around a beam bar in the center. And we also, because it's an ILS, we're displaying now glide slope information down the right hand side of the screen. Once again, we're also displaying heading across the top, and we may well be displaying a DME distance when we're closer to the ground, close to an ILS station. It's also showing us down here that we are displaying ILS information. We can then move on to another type of display. These full rose displays would very rarely be used on the aircraft. We've now moved on to the more modern presentations of map or expanded scale. So we'll just have a look at the expanded scale form of VOR and ILS display. First of all, if we go to the expanded mode of the VOR, we're now showing a very much compressed form of the compass. So we're showing something like a 60 to 70 degree compass arc. still showing our same VOR beam bar in the centre, and we're also showing that it's VOR information, wind information, distance from the station. Again, we can display a similar type of display for an ILS, and I'll just select that through now. And again, we can see on here a similar presentation of an expanded arc compass system showing roughly 70 degrees of arc, wind that we are displaying ILS information, and our glide slope information is also present because it's an ILS display. The modern presentation and the way in which the aircraft is generally flown, because we have the information available, is it would normally be flown in map mode. The modern EFIS system is a great benefit to pilots. I personally have been using EFIS systems now for the last 10 years, and they display so much information compared to the old mechanical instruments that they keep pilots far better spatially aware of where they are and what the aircraft is actually trying to do at any particular point in time. So most pilots have changed across to the EFIS displays and would be extremely reluctant to go back to conventional electromechanical instruments. The main display that is used on the EFIS instrument would be the map display. This would be the normal mode of operation in cruise flight. It displays a number of pieces of information, far more than we can display on a basic VOR or ILS presentation. We have a number of pieces of information on here. First of all, I'll turn off our airfield indications here so that we can show the screen in a slightly less cluttered form. So first of all, I'll turn off the circles which represent the various airfields along the route. We can change the presentation as we go along. We can look at different ranges on the instrument. So at the moment, we're looking at a full-scale range of about 320 miles. So we can see there we're showing 160 miles to our half-scale deflection. And I can choose what presentation I would like to show. So I can decrease the range to show more detail on the map. So I can change this on to a 160 mile full-scale range, which shows us 80 miles to the half-scale point. I can change it all the way down onto a 10-mile range if we were approaching a waypoint. So I can change the full range from 10 miles out to 320 miles. And you choose the range you're using depending on the number of waypoints that you're showing at the time. The other pieces of information we have displayed around the screen, we still keep our expanded scale compass showing roughly 70 degrees. Other pieces of information that we have displayed, at the top we have our heading, our actual magnetic heading. The little magenta rectangle under that is the heading that we have set on our heading bug on the mode control panel. In the top left-hand corner, we're showing the distance to our next waypoint, which in this case is Linz. So we can see from the scale here that it is in excess of 80 miles, and we're actually 99.7 miles from Linz. It is also showing us our time that we're expecting to pass overhead Linz. So in the top right-hand corner, we're showing our ETA there in Zulu time, and that is tied in with the captain's clock. So we can display a number of additional items on the screen, depending on selections that I make on the control panel for the HSI. I can display, for instance, airfields, which can be displayed on top by selecting the airports button on the control panel. So I'm now showing a number of airports around the aircraft. These would all be airfields that are suitable for an aircraft the size of a Boeing 757. So as we progress along the route, Dave will be picking up weather reports for these various airfields around us so that we know at any time which airfields are available should a diversion become necessary. One additional display we can also superimpose on our map display is a picture of weather around the aircraft. So we have a weather radar which I can switch on now to show you the display that we're going to get. Our weather radar display at the moment, if we look out the window, in fact, we can see we're just coming up to a nice view of the Alps down below us. There's very little weather that's going to show on our weather radar at the moment, because there's very little cloud around. To give you an impression of what sort of things we'd see on the weather radar, we can also just tip the dish of the weather radar in the nose down slightly, and it will actually carry out a ground mapping function. So if I just tip the dish down slightly now, we'll see on the screen here that we're actually picking up ground returns from the Alps at the moment, and it's almost contoured in terms of yellow being the lowest ground up to red being the highest ground. If we were actually flying towards weather which we'd need to take notice of in the aeroplane, it would also contour the weather so that the red would be the worst of the weather, down to the green, which is the mildest form of weather. So we'd be using the weather radar to avoid the worst of the weather along the route. We'll now move on to the ICAS system, as displayed in the centre here. ICAS standing for Engine Indication and Crew Alerting System. If we deal with the engine indications first of all, we have displayed on both screens here a representation of the old traditional electromechanical instruments as fitted to older aircraft. So just running down the screen from the top to the bottom. First of all, the top indication here is engine pressure ratio. It's a measure of the amount of power that the aircraft is actually developing, or the engine is developing at the moment. Below it, we have our N1, which is one of the three spools in our RB211 535 E4 engines. So the RB211 engine is a triple spool engine, and we have indications on the screen here of N1, which is the main fan at the front of the engine, N2, which is the second stage inside the engine, and N3, which is the hottest section of the engine. So we've got three completely independent spools spinning at different speeds inside the engine. Also displayed on here, we've got exhaust gas temperature, which is showing us the temperature at a particular point within the engine. If we move now from the EGT down to the fuel flow, at the bottom here you can see it's indicating 1.6. That's 1.6 tons of fuel per engine per hour. The 757 is fairly typical of modern aeroplanes now. It's extremely fuel efficient, and it burns roughly 3.5 tons of fuel per hour in normal cruise flight. There would be an additional fuel flow in the climb when the engines are running at high power, but that is normally well compensated for in the descent, where we basically have the engines at idle thrust for the descent. So overall, you can plan the trip on roughly 3.5 tons per hour. Also displayed on the bottom screen, we have some additional engine parameters. Starting at the top, we have oil pressures. They're displayed both in an analog form by the small pointers and in a digital form in the boxes. We have oil pressure at the top with oil temperatures underneath, oil quantities below that, with 20 quarts being the normal full quantity on the engine. Below that we have an indication of vibration levels on the engine, and it will indicate the highest vibration on any of the three spools within the engine. In common, all these parameters on the screens generally have red line limits and yellow or amber lines displayed. If any of these parameters should be exceeded, then the colours of these displays will change, alerting us that there is a problem on a particular indication, and we can then investigate that further. Also on the top screen here, two additional bits of information. The first one is we're showing here on the top TAT, or total air temperature, which is indicating minus 34 degrees centigrade. The actual outside air temperature at the moment, outside the aircraft, as indicated here on the FMC, is minus 61 degrees. The difference between the two temperatures is due to the kinetic heating as the aircraft passes through the air. So we're getting something like a 25 degree temperature rise on the skin of the aircraft due to our speed through the air. If we look once again at the EPA indications on the top set of gauges here, we can see they're indicating 1.62 and 1.61. And that is the current power setting that we have on each of the engines. Displayed above that in green is the maximum power that we're allowed to use on the engines at this stage in flight. That is also reflected in the green chevron around the outside of the instrument. Additionally, on the bottom screen, we can change the display to reflect a status page. Selecting across the status now, we have additional information available. On the top line, we're showing hydraulic quantities in the three hydraulic systems that we have on the aircraft: the left system, the center system, and the right system. Directly below that, we're showing the hydraulic pressures generated in each of those hydraulic systems, again for the left, the center, and the right. Additionally, the next line, we have APU. This is showing us at the moment that the APU is shut down. The APU is our auxiliary power unit, which is a small jet engine in the tail of the aircraft that normally supplies electrical power while the aircraft is on the ground. It also supplies air to drive our air conditioning systems on the ground, and additionally to provide air for the air-driven starters on the engines. Now, you may have noticed this morning at Manchester that when we started, we required a ground air cart plugged into the aircraft. The APU on board the aircraft today is providing us with electrical power if required, but it has a small problem with its compressed air supply, and it's not actually producing enough air for us to satisfactorily start the engines. So in Manchester and again in Dalaman, we'll require external air carts plugged into the aircraft to achieve a satisfactory start from the engines. Additionally, on the screen we have an indication of oxygen pressure. This is purely an indication of the oxygen pressure in the flight deck crew's oxygen system. We have a completely independent oxygen system from that supplied to the passengers. And at all times we will have at least 3 hours oxygen supplied for each member of the flight deck crew. This is to cover such eventualities as decompressions, where we lose cabin pressure. It also covers smoke and fire drills which require us to use the oxygen masks in flight. So this is one item that we do need to ensure before departure, that we have sufficient quantity in the oxygen bottle depending on the length of the flight we're going to undertake. Additionally, on the bottom screen we have an indication of our flight control positions. The 757 is a hydraulic aeroplane in that the primary flight controls on the aircraft are all hydraulically powered. There is no physical mechanical connection between our flight controls in the cockpit and the flight controls on the wings and tail. So it's essential that we can confirm that these controls are responding to flight control movements in the cockpit. And we can confirm that on the ground by checking the status page and checking that the control surfaces do move when we move the control column in the cockpit. On the screen at the bottom here, we can display rudder position. On the outside, we're showing aileron positions for the left and right aileron. And we're also displaying elevator position. And as the elevator is split into two parts, a left and a right, we can show independently the positions of the left and right elevator sections. A further item on the bottom screen is a display of brake temperatures. We see one square represents each of the main wheels of the aircraft. It is only the main wheels of the aircraft that are braked, so there are no brakes provided on the nose wheels to the aircraft. So each of these temperature gauges is monitoring each of the wheels on the aircraft and its brake temperature. So it shows a display within the box from 0 to 9. 9 being the highest temperature and 0 being cool. So we can get some indication after landing of the amount of braking we've been used, whether we have hot brakes on the aircraft, and whether we need to take suitable precautions as the aircraft comes onto stand. Generally, for normal operations, we would very rarely see these brake temperatures move above an indication of 2 out of a scale of 9. If we were to use fairly heavy braking in some sort of abnormal situation, then we might see them rise to 5 or 6. The bottom screen can be displayed, as we've seen already, in 2 different forms. One displaying secondary engine instruments and the other one displaying hydraulics and flight control positions. But in flight, it's our choice as to which we choose to display, and we may in fact choose to display a completely blank screen on the bottom, allowing the system to alert us if there is a parameter that goes out of limits. It will flash up the required display on the screen to attract our attention. So we could turn the screen completely off. In addition to our ICAS displays of engine instruments, these screens are AC power driven. In the event of a loss of AC power on the aircraft, we still need enough information about our engines to be able to fly the aircraft. So we have a set of standby engine instruments which are DC powered. These give us engine pressure ratio, N1, EGT and N3. That is enough basic information in conjunction with our standby instruments to safely fly the aircraft. We now come back to the top ICAS screen to look at the crew advisory system. I'll just turn the secondary standby instruments off again here. The additional function provided by the top screen here is it can alert the flight crew to potential problems that are occurring on the aircraft. There are 3 different levels of alert which can be presented to us by the crew alerting system that is incorporated within the ICAS system. Depending on the severity of a problem that is occurring at the time will depend on what priority it occupies on the top screen. We have 3 basic levels. We've got a basic alert, which would just bring up a simple message on the top screen. This can be demonstrated by selecting one of the windshield heat switches off, which will generate just a simple alert with no audible tones. We can see now we've just generated an alert on the top screen which says left side window. So if that was occurring for real on the aircraft, I would be calling to Dave for our checklist items for a left side window. The next level of advisory message is a caution. The caution is a higher priority than the alert, and because of that it also needs to attract our attention. This can be demonstrated by disengaging the autothrottle in flight. We will generate, as you can see, an ICAS message, autothrottle disconnect. We generated an audible tone plus a master caution. Our normal course of action would be to cancel the master caution and for me to call for our quick reference handbook checklist to address the autothrottle disconnect. In this particular case, we're just going to reinstate the autothrottle system. We have a 3rd level of advisory on the aircraft, which is the warning. This would be typified by an engine fire, an APU fire, or in this particular case by an autopilot disconnect, which obviously at the wrong time of flight could be a particularly critical situation, especially if carrying out an autoland. So for us today, we can generate that warning by disconnecting the autopilot, and we'll see the generation of a warning on the ICAS screen plus a master warning in red. So I'll just disconnect the autopilot now. Once again, a master warning would normally be addressed by registering the problem, cancelling the master warning, and then calling for either memory items or a QRH drill to deal with it. I'll just re-engage the autopilot again now. So if we look on the bottom screen here, we can see our route, and we can see we're approaching our top of descent point, represented by TD in green on the screen here. It's approximately 25 miles away, so we're going to be starting our descent in about the next 3 or 4 minutes. So we're now going to request descent from air traffic control, and if we keep our eyes on the thrust levers as we get to the top of descent, we'll see them come back to idle as we settle into the descent.
Tourjet 179 Papa is looking for descent this time, sir.
Jet 179 Papa is on descent to level 240.
Reclear to flight level 240, Tourjet 179 Papa.
Okay, so if we set on a lower level now, we're cleared to flight level 240. We'll set that in our window, re-engage our VNAV mode, and if we watch the thrust levers now, you'll see them start to retard to start our descent. So we're slightly higher in the profile because we started our descent a little late there, and the little magenta triangle diamond is showing our descent, and it's showing that we're actually high on the profile at the moment. So the aircraft will now attempt to regain the profile. So we can see as we descend down, the thrust levers are now idle. We can see the altimeter starting to unwind. We're descending at about 3,000 feet a minute at the moment. That will average out to about a 2,000 feet a minute rate of descent over the entire descent profile. Right, if we just run through the brief now as we head towards Dalaman. Okay, so first of all, on plate 10-2, dated 26th of September 97, the arrival procedure for Dalaman. We're expecting to arrive...
Recleared 150 for Tourjet 179 Papa.
Thank you, 150C. We're expecting to arrive via Kavak, which is selected in the FMC. So coming from Kavak towards Dalaman, sector safe is flight level 100, so there is high ground around to the north of the airfield, so we need to be aware of that. We've both read the airfield brief, and we've seen the notes about high ground around Dalaman. So we're proceeding down towards Dalaman. Once we're within 10 miles of Dalaman, we can descend to 4,500 feet. If we're visual, of course, we can descend earlier than that, as long as we can possibly see where we're going. From there, we'll come on to plate 13-1, which is dated the 22nd of August, 97. And there's a VOR DME procedure for runway 01 at Dalaman. Again, it stresses the high ground around the airfield. We can see spot heights up to 3,500 just off to the northeast of the airfield. There's also spots around slightly to the east of the airfield as well. So any circling manoeuvres to be carried out to the west of the field. So initially we're expected to be cleared towards the Dalaman VOR, which is selected on the number 1 VOR and is also backed up on the number 2 VOR. We can expect radar vectors, but if we fail to get radar vectors and we're not visual, then we can expect to carry out a procedural VOR DME approach for runway 01. In which case we will come over the top of the beacon, initially at 4,500 feet, which is a sector safe. And from there, we'll come outbound in a teardrop. So we'll come outbound on about 210 to 8 miles, and then make a left-hand turn to establish inbound 010. 010 is selected on the number 1 VOR. There's an ADF on the field also, 346, which we've got selected on both boxes. So outbound in the procedure, we'd be descending down to 2,800 feet once we pass the Dalaman VOR.
Yep.
A left-hand turn to start our descent inbound.
129.5 for Tourjet 179 Papa. Bye-bye, sir.
Okay, if you just call Dalaman and we'll complete the briefing afterwards.
Okay.
Dalaman approach, good afternoon, it's Tourjet 179 Papa with you passing flight level 200 for flight level 150.
Tourjet 179 Papa, good afternoon, radar contact position 4 miles north, fly direct to Dalaman, descent flight level 100, QNH 1018, information Tango.
Roger, 1018 information Tango, direct to Dalaman and re-clear to flight level 100 for Georgia 179 Papa.
Okay, cleared to flight level 100.
See.
QNH is 1018, so that's on the standby for the moment. So as we were saying, outbound, descending to 2,800 feet, we need to configure in the turn, so we'll take our flaps and gear in the turn so that we're ready to descend inbound at 8 DME. The angle of approach is going to be fairly typical, so we're talking about a 5% approach inbound, so we're looking at typical 700 feet a minute, 800 feet a minute rate of descent. Descending down to our minimas, and we know our minima is set at 850 on our altimeter bug. In the event of a missed approach, the missed approach is to climb to the VOR DME, continue climbing on the 008 radial to 2,400 feet within 6 DME, and then turn left away from the high ground here, climbing to 4,000 feet back to the VOR and take up the hold. And there's a speed restriction of a maximum of 185 knots until inbound to the VOR to keep the turn under control and keep us away from this high ground end here.
Okay, VOR identified on the right hand side.
Thank you. We've got the speed brakes deployed at the moment. The speed brakes are like panels that lift up in the wing to assist by destroying the lift over the wing. They help the aircraft descend faster. So although we keep our same indicated airspeed, we're actually descending. Our rate of descent becomes higher. Just approaching our level off altitude of 10,000, so we've stowed the speed brakes and we'll reduce our speed now back to 250 knots, which is standard below 10,000 feet.
Jet 179 Papa, right heading 190 for vectors final runway 01. This altitude 4,500 feet, 1018.
Roger, heading 190 down to 4,500 feet on 1018 for Georgia 179 Papa.
Okay, and that's seen.
So we're cleared down to 4,500 feet now on the QNH of 1018. And again, because we're quite high at the moment, we use the speed brakes once again to assist us down and reduce our speed back to 250 knots below 10. Okay, we'll just identify the VORs. So Dalaman VOR is identified on box 1 and I'll remain on that this side. And we'll have the approach checks, please.
Altimeters.
6,000, 1018, once, twice, 3 times.
Iris approach 8.
Identified.
No smoking sign.
The smoking sign is on.
Cabin crew PA.
That's been given.
And approach checks are complete.
Thank you.
Where do you want to go?
Change tower 185.
Roger, continue with the visual 1018 and to tower on 118.5 for Georgia 179 Papa.
Okay, so the field inside, I've set us up to descend to 1,500 feet.
Let's see.
Okay, we're on 1018. We'll take it out to a reasonable distance. Ourselves time.
And Dalaman Tower, good afternoon, it's Georgia 179 Papa with you, just passing 3,700 for 1,500, and we're visual with the field this time.
Jet 179 Papa, good afternoon, wind 200 degrees 06 knots, clear to land runway 01.
Roger, clear to land 01, Georgia 179 Papa.
Okay, flat 1 please.
Be good. That one selected.
We'll take it out far enough so we're not too cramped on the circuit here.
Yeah.
Okay, we'll start our turn around now. Flat 5 please.
That flight selected.
The radio is active. We can start the APU.
Less than 1 to go.
Check. Speed brakes in now. And if you want to give the intercept leg to the runway, please.
And executing.
Thank you. And we'll take gear down, flap 20, please.
And flap 20 selected.
Okay, the autopilot's coming out now. And the flight director's off. And we'll have the landing checks, please.
The landing checks, speed brake,
Is armed.
landing gear,
It's down 3 greens.
cabin secure,
Cabin is secure.
Are you happy for me to go across or just
Okay,
leave
we'll
it?
take flap 30 first, please.
Okay, flap 30 selected.
And if you can set VREF +5,
Okay.
126.
126
And a missed approach altitude of 4,000 feet.
and 4,000 set.
Thank you.
Off the air for 2 secs.
Okay.
Okay, back with you. Through 1,000 feet.
Okay. The man land fully visual. Just slightly high on the profile at the moment.
And that's understood.
Flap 30 and the landing checks are complete.
No speed brake. Speed brake you have. Reverse both you have. $80 knots.
Manual braking.
And 60 knots.
79 Papa, first deck, number 5.
First exit number 5, Tourjet 179 Papa.
And number 5 is on the other side of the tower block, just to let you know.
Okay, and the after landings, please.
Coming out with orders.
Thank you.
TCAS, system test, okay.
Okay, AP is running, engine anti-ice is off. And those lights are on.
Just for taxi, thank you.
Just the taxi, I think.
Yeah, that's fine.
And nose is off.
Okay, the APU is running, engine icing's off. And the shutdown checks, please.
Okay, shutdown park brake,
Is set.
fuel control,
Cut off.
hydraulic system,
Is set.
fuel system,
Off.
seat belts,
Are off.
and just waiting for the monitors.
Okay, so signalling chocks are in.
And
Okay,
IRS
that's
is-
good. Are off.
Okay, shutdown checks are complete.
Thank you.
very much, Rex.
Well, welcome to Dalaman. As you can see, it's a beautiful day here. Temperature's 22 degrees. I hope your flight with us today has given you an insight into the operations of a Boeing 757 aircraft. It's very much a team exercise. There's 2 flight deck crew continually involved in the process of navigating and flying the aircraft, and also we have a good team behind us looking after the safety requirements of our passengers. I hope you've enjoyed the program today, and I look forward to seeing some of you on one of my flights in the future. Thank you.